So today's panelists include Kathryn Hume, VP Digital Channels Technology at RBC, Nijan Giree, Director Mobile Development, Digital RBC, Arup Saha, Director Android Development RBC, and Alex Lau, Senior Director Android and Mobile Services Development. Take it away.
Okay, so as mentioned today, we wanted to talk about the process that we've been through in having our Android team. So folks that are coming from the full stack object-oriented development paradigm work to build machine learning models on our own. So within RBC, we've historically thought about machine learning and data science as a centralized function. So there's a group that I used to lead called Borealis AI that was the kind of machine learning center of excellence for the bank, building out and doing research on new algorithms. And they do continue to do so, but as we've noticed over the past 10 years since, if I think back to 2012 when the first ImageNet paper came out where Jeff Hinton and Ilya were applying deep learning to do image classification tasks. We've come a long time since then, right? So Keras, I think the first time Keras came out was like 2015, and it was just a brand new library. And back in 2015, I was working at a company where we built out a prototype showing how you could reorder your Instagram feed based on the objects that were in the image. And at the time, it was super buggy, and there were all sorts of faults with our convolutional neural net classification algorithms. And 10 years on, it's just much more ready for prime time, right? We've kind of stepped out of the research lab and moved into a position where teams like ours, who are responsible for building applications that tens of millions of clients use on a daily basis to do their finances, we can reliably apply algorithms in context to solve those client problems. So I think there's a reason why we're doing this talk now, which is that the toolkits have evolved to the point where there's lower barrier to entries for non-PhD machine learning scientists to develop and engineer products using machine learning algorithms. And we're going to tell you a little bit about our journey into making things work. We also noticed that there's just a broader business adoption to want to do things in applications like personalized features for users, which are intrinsically ML-driven features that touch our team, as opposed to our just doing kind of niche POC experiments with algorithms that may or may not work in the research lab. And then the third thing that we think is changing and why this is a relevant topic in 2024 is the rise of LLMs. And we will talk about how the barriers to entry for software developers to using LLMs is quite different from those that exist in building statistical-based algorithms. So we'll talk about some of the differences in like how to be a great prompt engineer as opposed to how to build an algorithm from scratch using data and various algorithm design. So we talked about the team. We won't go through doing introductions. I have the mobile and web team, and Alex, Arup, and Nijan are very proficient experts in Android code. But Alex, I'll start with you. So you're accustomed to picking up a new framework, a new programming language. Tell us what was different, or what's kind of structurally different in moving from a new framework, the difference from a framework to framework versus like picking up ML.
Thanks, Kathryn. In terms of learning new technology, thinking way back, mobile was new. It's still kind of new, but not as new as before. None of us started, right off the bat in mobile. Like, some of us have services development background, others type of background. So we're no strangers to picking up like new frameworks, new stack, completely new stack. But I think what happens is, we graduate from university. Once we join the workforce, we focus and hone on certain aspects of software engineering. Object-oriented, how do you create good abstraction, how to write good software, reliable software. And as we progress in our career, that's the part that gets really a lot of focus. So when we talk about learning stuff like machine learning, it's like lost muscle memory almost, right? Now you suddenly have to figure out, these new data structures, creating vectors as inputs. What does it mean by batch size? Training the epochs and all that stuff is all. You just have to revive it from your memory. So I think that's one of the hard part is to kind of revive that part of your brain that you have not, overly used. And another thing is when you learn a new framework or new language, we tend to draw parallels. So first some of us started with C, C++, and then Java, and then now even Kotlin. They always you can draw parallels. This data structure in Java is equivalent to this data structure in Kotlin. Even something more groundbreaking, like in Kotlin, the multi-threading constructs have changed to coroutines. We can still kind of draw parallels to that. So it's easier for us to understand as software engineers. But it's hard to draw that parallel when it comes to machine learning. There is no you can't make the connection immediately. So again, that's one of the challenges, another challenge that we have to kind of overcome.
One thing that's interesting, I was thinking back to this post that Andrej Karpathy, who's I think he's at OpenAI again. He was there, he left, went to Tesla, he came back to OpenAI. He has this famous blog post from 2017, 18-ish that talks about using machine learning as a new kind of computer programming paradigm. And what was interesting is in that piece, he basically says, when you're doing ML, you're at this different level of abstraction, where as opposed to hand coding if-then rules on how to work with your data structures, you're basically stepping back, articulating some set of criteria for what your algorithm to do, and just letting it go on the data and learn. So I'd love Arup or Nijan for you guys to comment on. It's almost the opposite of what Alex said, in that it's he paints this picture where it's you're a little more hands-off when you're a machine learning engineer and you're letting the algorithm do the work or back propagation, whatever you're doing in ML, to figure out what the best actual structure for your function is, as opposed to defining the structure of your function. And yet it also requires that you go deep into kind of the first principles of comp sci. So I just would love your comments on that, in terms of whether it's easier or more difficult when it comes to just the basics of efficient algorithm design.
Sure. Yeah, so I would say it is easier to understand these ML concepts, since we already have a lot of the kind of the educational background when we're doing computer science. But I think that's up to a certain extent. I think at a kind of a high level algorithm, it's pretty straightforward to understand back propagation and gradient descent. But I think it does get very complex when you look at kind of all the research papers out there for a regular developer like myself to kind of be able to keep up with all that knowledge while still kind of doing my day job is very difficult. But I think if you have time to look at kind of these broad core concepts like backpropagation, gradient descent, cross-validation, those kind of core ML concepts, those are really straightforward to understand, but going to a deeper level is pretty difficult.
Yeah, so there's some very core essence of ML concepts that you need to be proficient in order to take this leap, but you don't necessarily need to go into every flavor of algorithm design. There's work that is improving algorithm on benchmark tasks and the work that an ML researcher would do, but then there's these kind of must-have concepts that are needed so you know what you're engaging with when you're using ML. How about your thoughts on it, Arup?
Yeah, I have very similar, I think, thought process as Nijan mentioned. So when you are using, I think, the ML, it's, I think, initially when I started, for me, it took some time to understand, because I think we always try to parallel, right, what we have learned in the construct of object-oriented programming, in the construct of Java. We try to parallel in machine learning, but I was not able to draw that parallel. And so I had to start from scratch in the ML world, where I had to understand what backpropagation is, although I have learned matrix multiplication, but I forgot. So I had to reinitiate the other part of the brain, where I need to have that understanding, or I need to focus on the part of understanding what matrix multiplication is, what feature extraction is, and why matrix multiplication would be important in order to identify a feature that is relevant in that model that I'm building on. So I think understanding this, once you get into it, it's probably not that difficult, but in terms of when you're using them in order to generate or build the model. But I think going to the further research into it, bringing, for example, optimization, right? You want to optimize your model for better performance, right? There are already laid down several techniques of optimizations, so you could use them, right? That's easy. But if you want to have on your own some additional optimization, that's where you need to do the research. And that's where you need to spend a lot of time understanding the very inner concepts of them.
All right, let's talk about more concrete use cases, so abstractions. It would be useful at the end, we'll talk about tips for success, kind of any references you have for like blog posts or resources that you found really useful in learning these things. But more practically, so there's 2 use cases we wanted to speak about to go into like, what were the actual ML problems we solved and what did we learn along the way? Let's start with the bill pay check use case, Nijan.
Sure. Yeah. So, So I guess everybody has kind of used bill pay on their phone or maybe in the branch. And if you have ever used it, then you'd know how difficult it is to find the correct payee and go through the flow and pay your bill. The first time you're having to pay, it's always difficult. So we kind of identified that as a problem for us, and I think Arup was the one that actually thought of using OCR to have the user capture their bill right at the start of the flow, because you have your bill there, you just take your phone out, you capture the image, and our app will pick the correct biller for you. So that was our original kind of problem and idea. So what we ended up doing there was we kind of had multiple phases. The first phase was we built a in-house kind of heuristic approach to getting the OCR data and then figuring out which bill rate belongs to. And that worked great for a lot of bills, but that only worked for bills that we had data for. So for example, if we knew that RBC would be at the top and we'd have like a postal code with the RBC, the mailing address, then we can map that biller to the database and it'll work fine. But then we ran into a scaling issue where we have a lot of billers, there's thousands of billers, and we can't manually add all that data. So what we ended up doing was we created a ML model to use the OCR data and use the key features in that OCR data to map those bill data to the actual payee. And we built that with the data that we were capturing using the first phase, and it was really successful, and we were able to add a lot of billers that we had no data for in-house. So with that solution, a user can scan their bill. If it's something that we've never seen, we can use that data to train future models. So yeah, that was the flow, and I think it made the entire process of adding a biller a lot smoother.
Did you come up with the problem just because it was kind of like this is a pain point, or was it what was the origination of the problem statement?
Yeah, I think maybe Arup can answer that one, but I think it was definitely a pain point for users.
Yeah, so the pain point that we had, so normally like in order to find, so there are 2 pain points. So one is when you add a biller, you have to search the biller name, right? Now, we all know that biller names, so for example, if you want to pay a bill to Bell for internet, so if you search with Bell, there will be 4 or 5 entities for Bell comes. Now, as a user, you do not know which one is relevant for your internet. So that was the first problem. Second one was you needed to enter the account number, right? And that account numbers are 16-digit account numbers, and they are alphanumeric. Now, entering a 16-digit alphanumeric number at one go, it's a big challenge. And especially for, I think, my mom or like, for them, it is a lot more challenging. So these are the challenge I think we encountered.
And what did you learn most when you went through this? Like, what was the hardest technical problem, and what did you walk away with?
Yeah, so I would say, I think I learned 2 things from this, and they're kind of related. The first thing was how important it was to have that initial phase, even though it wasn't done in ML. The initial phase where we can actually have a solution for the user to actually be able to scan their bill, even though we didn't have the data to build a proper ML model, having that first phase to kind of gather that data was really important. Without that phase, we wouldn't have been able to generate that model. So that was really a key learning for us. And the second one, I guess, is kind of maybe for me, but I didn't really understand, like, we think of ML and we think of it as, it's the model that we put in there, and kind of forget the rest of the system. But there's a lot of things that we have to build around that ML model. So we have to build the capability to kind of, capture the correct data. We have to clean that data, and then we have to be able to use it in the proper location where it makes sense. So all that is kind of things that support the model, but without that, the model wouldn't really work well.
Yeah, that makes a lot of sense. In an algorithmic system, it's like there's all of the data capturing, cleaning, the pipelines that feed data as an input into the model. You get the output. Often there's like a threshold you have to define. So the output might be some percentage likelihood that X thing is the case. And you need to define if it's above or below that likelihood with some rule. Do you do like the first action or the second action? So in the composite design, it's not just the little model, it's everything around it. That makes sense. Second use case, so this one around predicting users' intent in the app. As I mentioned at the outset of our session, there's a lot of focus on personalization right now where we work at RBC. And so in our early forays into personalization, we were trying to experiment with our ability to capture clients' behavior in the app, so their utilization of different pages to think what they might do next. So Arup, tell us more about that and your approach.
Yeah, so I think the intent prediction use case is basically predicting the user intent when the user is using our application. So understanding and predicting user intent is a key component in design and development for the user-centric applications. And I think specifically for the banking applications, that's what we believed. And with that belief, we wanted to improve our user experience. And like as a large mobile application grows, you add more and more features into it, right? So findability of a feature is always a challenge for a user, and this impacts to their user experience and then user satisfaction of using the app. So we wanted to improve the user experience and find out how we can help user, like in order to predict what could be their intention to perform as the next action. So that was I think the use case that we tried to solve and to improve the user experience and their satisfaction. That was the whole intent.
And how about with that one? What was the hardest part? What did you learn?
I think the challenges were like multifaceted, I would say. Like I think the first one, I would say capturing the data, because we've like once we identified the problem, the next step was data collection and data preparation. So we were at the time like thinking about what data would be able to help us. And then after some research, we came up with the analytics data where we are able to see the screen visits and the user actions. So that might be able to give us our data to predict for the user intention. So we relied heavily on analytics data, historical analytics data for this particular use case. And we explored several ML models, like traditional ones like support vector machines, decision tree, random forest, and then neural network as well. So it was a very good learning experience because we were able to explore different ML models and compare them as well in terms of their performance, the hyperparameter tuning, and the I think biggest learning that I had while working on this is your model is as good as your data. So if your data is not good, you cannot expect the model to predict a good output. So we actually iterated over, I think, the data pre-processing step several times. And once we have the realization, and we've put actually a lot of effort in the feature engineering piece of the work as well. So that was, I think, my biggest learning. That's that cool. Your data quality should be very good when you are building an ML model.
There's another thing you said as you went through the different model types. We used to always say at Borealis, you start with the simplest possible solution that will solve your problem at scale. This isn't always the preferred method of scientists who are super interested in exploring the latest techniques, right? So they sort of start with a very big hammer that would be needed for super high dimensional data, but that's not always the case, in particular when you're using kind of structured, like client behavior and analytics data. So it's always helpful to start with like some baseline performance on a relatively simple model and then explore whether you can get improved accuracy or whatever kind of performance metric you're using with a more heavier and complex tool, and then settle on that, because it can be harder to maintain a more complex model, and then there's the standard issue of kind of explainability can decrease with the relative complexity of the dimensionality and the internal characteristics of the model. Okay, slight shift in gears, then we'll save some time for questions. Just a couple of minutes on Gen AI. So different kind of paradigm, but again, we're exploring both small and relatively large and ambitious applications of client-facing LLMs. Alex, I'll pass it to you, kind of your early explorations on this in thinking about like writing a great prompt versus exploring a traditional ML problem.
Is completely different. To a sense that so traditional ML, you kind of read the paper, you're like, oh, okay, the math kind of makes sense, but at least to me, I'm not sure about you guys, it's still magical the way the LLMs work. So, but then I think recently, as it becomes more prominent, we're starting to see traces of kind of software engineering and software design being applied in that realm. And we're able to treat some of these prompts like we would a piece of software, a function, if you will. So if we look at it from that perspective, the comfort level goes up. So you know, okay, well, let's craft a prompt. Let's craft meta prompts, prompt for a prompt, that kind of thing. So the comfort level goes up, and I think right now that that's definitely the hot space right now, and we're gravitating towards that. But at the same time, we have to be a little bit careful because, as a software engineer with a computer science background, we're always wondering in the back of our minds, why is it working? Right? At least for me, like, why is it working? Although it is working, why is it working? And that's where, especially in our field, we have to be a little bit careful about.
Do you guys want to share your thoughts?
Yeah, I can go. I think, as Alex mentioned, it's very different paradigm between using the Gen AI versus the ML model. I think entry to the Gen AI is a lot easier now as a software developer, right? Because I think you can just have your prompt. And there are, as Alex mentioned, I think your prompts is like you're writing your code. Very similar, if you think from that architecture, it is very similar. Like you have few-shot prompting, you have chain of thought, you have tree of thought. It's very similar like how you communicate, right? So that actually helps a lot as a developer to interact with this LLMs a lot faster. But then I think the other part that Alex mentioned is you want to be careful about how do you handle the hallucinations? How do you handle the inappropriate messages that LLM provide? And the other challenge would be like this context length. Like how do you provide the sufficient context to these models so that like you are not run out of the token limit, right? And how do you evaluate also the response that you get? Because you cannot take the response on its words. You have to evaluate and you have to validate these responses. So I think that's where the differences between the traditional ML models and the Gen AI models would differ. And I think it's, as Alice mentioned, that we are gravitating towards, but so we need to make sure that we have the guardrails for us to help us improve using of this more Gen AI apps and like using the LLMs.
So in the interest of time, any questions from the audience that we can answer? Oscar, do you want to go first? Saw your hand up first.
Sure. I'm actually really curious about the last point that you made, the evaluation piece. Are you guys actually engaging the data scientists who know how to evaluate machine learning models for the LLM applications as well? Or do you do the evaluation yourself? And if so, how do you do it?
You may want to repeat the question so everyone can hear it.
Okay, so the question was, when we are evaluating the output of an LLM, are we working together with the data scientists who have robust techniques to evaluate model quality, or are we trying to do it internally?
Yeah, so I think there are two parts. Definitely, like, we are reaching out to the data scientist who has more experience in this field, but at the same time, so we are engaged with researching ourselves as well. I think this is very much comes top down from Kathryn, from Alex, that we should continue research and improve our experience. So there are like several ways. So far we have evaluated, definitely human evaluation is there. On top of that, you can have another LLM evaluate your responses. That's definitely another one. You can build another ML model, right, to evaluate that responses, because you know what kind of responses you are expecting. So you can have another ML model like fine tune with your expected output, and you can evaluate your response that way. But definitely these are from our own research. We are reaching out to the data scientists who has more experience in this field.
We also haven't done this yet. This is more like we know some others in the industry who gave a talk who proposed this kind of framework, but I think it's really interesting. So as Alex mentioned, if we start to think about prompting within the framework that we would normally think about in an engineering, like coding a workflow in an engineering life cycle, or for lack of a better term, we would do a unit test on our subfunctions to see if they're outputting what they're supposed to output. So really interesting idea to think about an LLM unit test. And the output's not going to be standardized because the temperature parameter can lead to all sorts of crazy variations. But I guess the question is, might we design kind of a unit test-like framework for some sub-prompt in a sequence of functions? So that's of interest going forward, but we don't have anything like that in production yet today.
All right, we have about 1 more minute left.
Go for it. Take the question. Yeah.
So, great panel, by the way. Quick questions regarding how far is RBC's journey in the Gen AI implementation? I know, like, you're speaking more specifically in this area, but like overall, has RBC deployed any client-facing, not the internal ones?
Okay, so the question was, how far along is RBC in its Gen AI journey? So there's still a lot of reticence for certain types of client-facing LLMs, largely as it relates to, like, imagine a conversational bot that could output answers about your finances. So the risk team is like, you got to be kidding me, no way. We, on the flip side, Arup, this is more in the POC phase, but we think there's opportunities for more moderate and less risky client-facing LLMs. So one example is frequently we might have a service disruption in our pages, and it can be really painful for a client to come in and want to do an e-transfer, and then they're like, page is down. So we were thinking we might be able to use it to output some sort of generated summary about the status of an application page. And that one's not so risky, right? Like, worst case, it gets the details wrong, and the client, it says it's going to be done at 10 a.m. as opposed to 9 a.m. and the client is like, you said it was going to be up, right? So it's kind of like the risk tolerance around where the output might be, but so a smaller overall impact, but potentially less risky, so we can get the engineering principles for doing an LLM in the channel in place. A lot of the focus in the beginning has been on more internal knowledge management focused applications, and we're doing a lot with our coding practices. So the code generation, unit test automation, evaluation of the quality of our code stack. And there's a very robust centralized mechanism, we call it the LLM gateway, that is a provisioned, governed instance of access to any third-party LLM cloud environments that's managed by our central team. We're pretty advanced in that. So we have kind of our hosted, centralized means of accessing these tools. And if you log into gpt.com or try to access that from your browser, you just basically get like, no. And then, I think they've caught up to Mistral, but like as these new foundational modeling company ups, we might have like a day where we're able to access it before everything gets locked down and we have to go through the gateway. So yeah, but we're working to try to provision, like, I'm a big fan of kind of a gang of LLMs. So provision environments where people can try to work on some task and have like almost like just a menu of LLMs that they could call, and then they could explore how the outputs vary and find the one that's of highest quality for whatever they're trying to work through. So that's again, future state, what we're looking for in terms of our kind of IDEs toolkit, but we're not there yet.
All right, everyone, thank you so very much for this panel talk. Let's give a big round of applause.